Hello, everyone. My name is Simon Stefan, and in this little tutorial, I want to talk about how we can set up the typical cognitive science experiment using jsPsych. So why do I want to talk about this, and why did I do this little tutorial? Well, I have recently, I think it was in last year or so, or maybe even a bit earlier, I have looked for a new way of setting up experiments. So now, those days where we want to test experiments using very large samples, it has become more and more unfeasible to invite people to a real lab, because we simply need too many participants to find subtle effects. And therefore, a while ago, years ago, actually, we have transitioned to conducting online experiments, right? Many of you will know online subjects to tools like Amazon Mechanical Turk or Prolific, where we can find and recruit participants online who can take part then in online studies. So as researchers or cognitive scientists, in my personal case, we need to find a way of setting up online experiments, right? And the tools I've been using for a long time were tools with which I was not so happy anymore. So I looked for something else. And then I discovered, I don't remember exactly how it happened, but at some point I discovered jsPsych. I came across jsPsych, and I must say it's absolutely amazing. And it's absolutely worth investing some time to learn how to set up experiments using this great framework. But then I soon realized that while the tutorial page, the online documentation for jsPsych, it is absolutely great. It is amazing. But my impression was that what is lacking a bit is a way to quickly learn how to set up a typical cognitive science experiment. So you can find a lot of examples for experiments that measure reaction times and stuff like that. But some elements that we use in cognitive science, and I must say that I have a background in causal reasoning research, there are some elements of typical experiments that were not covered so well on the documentation, in the documentation on jsPsych, even though it's absolutely great. So I decided to make such a tutorial myself, and thought that it might be of help to some people. And yeah, therefore I decided to record this. That was a bit of a lengthy introduction. So what I want to cover here in this little tutorial is basically this. So first of all, I want to say a little bit more about what jsPsych is, and quickly want to show what we can learn from the website, which is a lot, and it's so great, as I just said. And if at some point you're looking for something and this is not covered by the website, it's also absolutely worth checking out the GitHub discussions page, which you can find under this link here. But this is not going to be the main part of this tutorial. I guess that most people, or many people who might be watching this, are already familiar with what jsPsych is. So the main part of this tutorial will be the second part here, where I will talk about how to set up a simple cognitive science experiment. So what do I mean? What is it that I thought is a bit missing on this online documentary here? So in the typical cognitive science experiment that we use, for example, in causal reasoning research, there's a certain structure. For example, we usually have instructions that subjects have to read. And then something that I often use and that I find very helpful is to have a comprehension test or an instruction test, where you ask subjects about the critical elements of the instructions and of the information that they should absolutely know before they proceed. So what we want to implement often is some sort of comprehension or instruction test that subjects must pass in order to proceed. In other words, they cannot go on if they don't pass this instruction check. So how can we implement this in jsPsych? How can we set up an experiment that has this element of a comprehension test? And then at least in my area of research, the typical design of an experiment is a mixed design where you have a between subject factor or two between subject factor and one or several within subject factors. So usually subjects get assigned to one experimental condition or another experimental condition, and within each experimental condition they are going to see different things, which describes a so-called mixed design of between and within subject, between subject and within subject factors. And what most people also want to do when they run such a mixed design is to have either a random order or a counterbalanced order in which the repeated measures are taken. So I also want to show how after an instruction check or instruction test, how in the main phase of an experiment we can have between subject and within subject conditions or repeated measures in random order. And yeah, I first want to demonstrate, I have programmed such an example experiment. I will say more about it in a minute. I will first show that so that you can see what the ultimate goal is when we move to jsPsych, and I'm going to show how to implement this experiment in jsPsych. And then a last part, or it might even be a separate video, I will be saying more about how we can launch the experiments or this experiment. And this is a topic, or this is where we talk about how jsPsych meets cognition.run, which is another very great website I can highly recommend. All right, on to the next part. I should also say actually that I created a little tutorial page, which is linked in the video description below. And on this little GitHub page, you can download all the files, all the experiment files that I create during this tutorial. So you can actually download a zip folder here and see the code that I'm going to generate in this tutorial. And you can also click here to see a demo version of the experiment. All right, so first, as I promised, I want to say a bit more about what jsPsych is, even though all the information you can find here is actually quotes that I directly copied from the website. So if you go on this link here, you go to jspsych.org, this will lead you to the amazing jsPsych website, where you can learn all the stuff that is important about jsPsych. But yeah, before I show the experiments, I wanted to say what it is we are working with here. So jsPsych, this is somehow part of the name. JS stands for JavaScript. So jsPsych is a JavaScript framework for creating behavioral experiments that run in a web browser. So something that many people, I guess, are looking for. And so JavaScript is a programming language that has a wide range of applications. So can use it for many different kinds of things. So as the name jsPsych suggests, this is a framework that has already been tailored to the needs of psychologists who want to use JavaScript for setting up behavioral experiments, and therefore the nice abbreviation jsPsych. A very crucial aspect or concept, I should say, in jsPsych is plugins. And you will soon see what this means. But a short theoretical definition is given on the website. So plugins define the kinds of trials or events that should occur during the experiments. And some plugins define very general events, like displaying a set of instruction pages where subjects see some text and then can click a button to proceed to the next screen. Or you can use plugins to display an image or to record responses, like a keyboard response or the click on a rating scale that subjects see, or you can even play back sound. I have never used this before, or yeah, in general, record a button response. So these plugins, luckily, are not things that we have to program ourselves as users of jsPsych, even though it's possible to create own plugins, but I'm not going to talk about this at all. You can find more information on the website. We can get very, very far with the library of plugins that is already provided, or that comes with jsPsych. And a list, an overview of all these plugins is also provided on the website. It's a very good overview where you can very quickly find what you are looking for. Yeah, and then so there's this concept of a plugin, and then a second crucial concept for users of jsPsych is the timeline. So what we will be doing when we program an experiment in jsPsych is essentially using plugins to create elements, so the parts of the experiments, that we then put together in a timeline that runs from start to finish while subjects are working from start to finish in the experiment. And it is absolutely right what is written here in this quote. With these two concepts, a timeline and different sorts of plugins, it is possible to create a very wide range of experiments. All right. And if it should happen that you still get stuck, then you might also want to check out the discussions page, which I already mentioned. I quickly show you. Whoop. So this is basically a GitHub forum, one could say. You can click on this link and then see all, and then you get a list of all the different questions people have been asking. You can search, see if the question you have has already been asked, or you can ask a new question. And the people here on this forum are great. I once had a question and I got a response very fast. So this is a super nice way of getting help if the jsPsych page is not enough. All right. So let's move on, and I'm going to show the experiment that I want to program in this tutorial. All right, let's go to the experiment. This is the folder where I have all the files, and final experiment is this HTML file here. I'm going to double click, and then you can see that something changes in my browser. And this is the experiment. As you can see here, I programmed a version of an experiment that can be run as an offline demo mode. This might be helpful if you run experiments, you write up a paper, and then you create an online repository with all the materials. And then it would be nice to have an offline version that people can simply download and run in their browser to see exactly what the experiment was. And this could then take the form of a demo mode where users so other researchers, for example, might then choose between the different conditions. This is not what subjects can do, obviously. When they take part in the real experiment, then they are randomly or alternately assigned to the different conditions, right? But in the demo mode, it might be nice to select between the different conditions. You don't know yet what this experiment is about exactly. I'm just going to demonstrate a run of this experiment, and I select condition 1. And then there's some feedback. I chose condition 1. This is also something that subjects who really take part in the experiment won't see. The first screen that subjects would be seeing is this. I'm from the University of Göttingen in Germany, so this is why you have this university logo here. The first page in this experiment just asks subjects to confirm that they are using a desktop PC or a laptop. I usually include this to avoid that people take part with their smartphones or tablets, because this might mean that they are in a noisy environment, like on the subway or on the bus, or while they do their running, stuff like that. And then they might not be as attentive, right? So I usually ask them to confirm that they are taking part via desktop PC or laptop. And then I also ask them if they really want to take this study seriously. Okay, so some confirmations here, and then they move on to an instruction. screen. And in this case, what we learn here in this instruction is that there's a group of biologists working in a laboratory, and they want to find out what the effects are of certain chemical substances. In particular, they want to know whether certain chemicals cause particular genes to be expressed in mice. And then there's some more information down here, what these biologists did in this fictitious scenario. So what subjects learn here is that they tested the effects of 2 different chemicals on 2 different genes in separate studies. And in each study, they took a random sample of mice, and then this random sample of mice was injected with one of the chemicals, and then later examined to see how many mice in this group expressed the gene. And then there's also a description of a control group of mice. So there was another random sample of mice that did not get injected with the chemical, and it was also later checked how many mice in this control group expressed the gene. So the description here is one of a typical randomized control trial that is suitable to answer causal queries. In this case, the effects of a particular chemical substance on the expression of a particular gene. All right, and then subjects learn that they will be shown the results of these studies, and that their task is going to be to indicate how strongly they believe, based on the results that they are going to see, that the tested chemical leads to the expression of the tested gene. All right, this is the instruction. It could be more complex. There could be another instruction screen coming, but in this case, this is it. And then one of the most important things of this tutorial is this part here that we see now, which is the instructional comprehension test. So there are 2 questions. It could be more complex, obviously, but here I restricted it to 2 questions. This is the first screen with 1 question, which probes subjects' understanding of what the main goal of the fictitious scenario is. And this is to find out whether certain chemical substances cause certain genes to be expressed in mice. So this is the correct answer. Then I press continue, and then there's a second comprehension test question. How did the biologists test their question? So the right answer here would be the first one. They conducted experiments with random samples of mice assigned to control and treatment groups. But just for the sake of demonstration here, let me choose a wrong option. And then what I want to happen in the study is that subjects who don't answer these questions correctly get some feedback first. Unfortunately, you didn't answer all the comprehension check questions correctly. Therefore, we will show you the instructions again. So this should lead subjects back to the instruction screen, or the instruction screens, if multiple screens are used to give the instructions. And then subjects have to read it again, and then they go back and have another chance to pass this instruction test. All right. So now let me do it correctly. If I select the correct answers, then I want another screen, a different feedback screen that tells subjects that they passed all the comprehension check questions and that they can therefore proceed to the next part of the study. And then there's a short reminder here that they are now going to see, finally, the results of the biologist's experiments. So here's the first result. The first results of the fictitious experiments. We see a graphical illustration that I inserted here. This, of course, could have been provided in various kinds of formats. This is the one I chose here. So we see the 2 groups of mice, the treatment group and the control group. And then we see how many mice are expressing a gene in each group. And this is also differently represented here by these stacked bar charts. To give subjects both the precise understanding of the size of the correlation or contingency between chemical treatment and gene expression and the size of the sample. All right, and then there's the test question based on these results. How confident are you that the tested chemical causes the expression of the tested gene? And then subjects can give an answer. And in this experiment here, the orientation of the rating scale, so whether we are certain that it does not cause the expression of the gene, is on the left side or the right side. This is counterbalanced between subjects. All right. So we have provided our rating, and then we get an intermediate screen telling us that we are now going to see the results of the second experiment, which looks like this. And we are again supposed to inspect these observations or the experimental results here, and then we ask the same question based on the results of the study: how confident are you that the tested chemical causes the expression of the gene? And again, we can provide a rating on a rating scale, continue, and then we are done with the main part of the experiment. Then we assess some demographic information like how old a participant is, and then maybe a gender question. And then there's an additional text field where we can tell the experimenter about potential or about technical errors that we might have experienced. In this case, there were none. And then there's a short debriefing screen, and then we can click finish, and then we are done with the experiment. Okay, this was one successful run of the experiment. Just for the sake of completeness, I'm also going to demonstrate the other between subject condition. I just refresh the experiment in my browser, and then it starts again. So we just looked at the small sample size condition. Now let's do the large sample size condition. Now let me just select condition 4. Again, the confirmation screen, then the instructions, which are exactly the same as before. Then the comprehension test, which is exactly the same as before. And now we pass on to the main phase of the experiment. And now, as you can see, we are in the large sample size condition because we can see many more mice here that were part of the fictitious study. But we see the same contingencies as before. So the correlation between administration of the chemical and expression of the gene is exactly the same as before. And these two studies are presented in random order to subjects. So here we see the data set with the high contingency or strong correlation, and then continue and go to the next study. And here we have the results of the large sample size condition with the low contingency or small correlation. Okay, and this is again the experiment. This was the other between subject condition, and we're done with the study. All right. So just to wrap this part up before we finally move on to the programming or implementing of this experiment, what was this experiment about? As you might have guessed, this is an experiment on causal inference. As I told you, I have a background in causal reasoning research, and the question that this experiment might be answering is the following: how do sample size and effect size influence a reasoner's confidence in the existence of a causal link between two factors, factor C and factor E? And what we have seen now in this experiment is essentially the following. As you know, the relationship between two binary variables can nicely be represented in a contingency table. And this is essentially what we saw in the experiments with the little mice. It's just a bit more accessible and intuitively understandable with these mice panels. At least that's the hope of this, that this is what it does. But in an abstract form, this could be represented. What we have seen and what we have seen could be represented in such a contingency table. So, for example, this is the data set with the small correlation or low contingency. This is the one of the same sample size, 32 observations in total, with the high correlation. And then this was the within subject factor. These two tables here, these two data sets were presented in a random order, and then there was the between subject factor, which was sample size, and in the high sample size condition we have just seen, we made these observations here summarized in these contingency tables here in the second row. And yeah, as you can see from the numbers, this was a large sample size condition in comparison to this one here. All right. So now let's move on to programming this experiment in jsPsych. Okay, what I did here is to create an empty folder that I called demo experiment, and this is where I'm going to put all the necessary files. I'm going to start from scratch here. I first go to the website because, as I said, jsPsych is based on plugins, and we need to download the framework. We need to download all the necessary files, mostly the necessary plugins. So if we go on this tutorial tab here and then to the very beginning, the basic Hello World example, this is also where we find the description of how to get these files. And I'm going to take gonna go for the second option here, where I'm going to get a zip folder with all the necessary files, and I can save them to my hard drive. So I click on this link here and then I save it into this folder I just created, demo experiment. This is where it's going to go. So let's go back to the folder and wait until the download is completed. And now I'm going to extract all these files here. It might take a few seconds. Yeah, and I guess it's worth to go back to this website from time to time and to download the most recent version of the jsPsych files. As you can see here, there have been several versions already. At the moment, we are at version 7.3. And by downloading this folder again, I ensured that we have the most recent files. Okay, this is absolutely essential. We can double click and then we see a lot of files. And I think, yeah, in this dist folder here, this is where all the plugins are that we can use in our experiment. Okay, but I'm not going to talk about this. Another thing that we definitely also need is a folder called EMG. You could name it differently, but this is the most usual convention. And this is where we are going to put all the images or stimuli that subjects are going to see. I've shown you the experiment that exists already. So I'm going to the folder that already exists, and I'm simply going to take these files and transfer them to this new image folder I just created. Okay, now we're almost good to go. One more thing that we need is we need a file in which we actually program the experiment. And for this, we can use any editor we want. For example, so what we need to create is an HTML file, which can be done with many different editors like Notepad++. I'm going to use a different one, which is Visual Studio Code, an editor I've come to like a lot. Okay, so I'm just going to open this. Now you already see the code of the existing experiment, but this is not what we want to look at. We want to set it up from scratch. So I'm going to open a new file. Then we have an empty editor here. Now I'm going to save it. In this folder I just created, to which we downloaded the jsPsych files and created the image folder, and this is where I'm going to save this file as an HTML file. And now this is an empty file, and we can begin to set up our experiment here. So now we get started. And as I said, this is not a tutorial that is going to talk about the basics of jsPsych. So I assume in the process of programming this or setting up this experiment that the viewer is already familiar with how jsPsych basically works and has worked through maybe the basic Hello World tutorial or even the simple reaction time task that is described here on the website. and also covered, I think, by some of the official tutorial videos that I'm also going to link. So what I mean is that things that need to be there in every jsPsych experiment that we set up, that this is already a familiar thing. So for example, every experiment in jsPsych begins with this sort of header here. For example, with these HTML tags that once we are done with programming also need to close the experiment. So at the very end, when we are done with programming, we also need to have like this tag that closes the whole thing. All right. And what you also have learned from the more basic tutorials is what all this stuff up here is, namely the embedding or activation of certain plugins that we are going to use. So which plugins did I activate here? Well, this jsPsych plugin always needs to be activated. And then there are plugins that vary from study to study. For example, here, this is the HTML button response plugin. If you remember, in the experiment, there were instructions where subjects had to click a button to proceed. And this can be done with this HTML button response plugin. So this is a plugin, I guess, that you will almost always need in every experiment. Then we also saw in the beginning of the study that where subjects had to confirm that they were willing to pay attention and take the study seriously, gave their responses with multiple choice in a multiple choice format. And this is why we have the multiple choice plugin, survey multi-choice plugin activated here. Then when subjects saw the results of the study that the biologists conducted there, they gave a rating, a certainty rating, right? And this was done using a rating scale. And this can be done using the plugin Survey Likert, the Survey Likert plugin. Whenever you have visual stimuli like pictures in your study, it makes sense to preload them before they are displayed on the screen in the experiment, to avoid that subjects see a blank screen for a while or just the text, and it takes a while until the picture pops up. This problem can be handled by using the plugin preload, the preload plugin. And then what we also had was an open text question format where subjects could, for example, report technical problems they might have encountered. And this is done with the plugin survey text element. All right. I also in this study, or for this experiment, did some custom styling. So I had the text in the block format, for example. So I also have this part here where I modify a little bit how the experiment looks like. So this is not something that is strictly necessary. So you don't have to have this, I guess. All right. So how does this start now? After this initial setup and loading of plugins. As I said, I wanted to have some optional styling. We don't have to pay much attention what I did there. I just inserted here so that what we do now looks exactly like the experiment that you have just seen. So this is all optional. You don't need it. You can also just neglect it if you want. All right. So then there's another part. This is already more important. Every jsPsych experiment needs to be loaded or made active. And this is done. So this is something that returns in every experiment. You have to have this global thing here that specifies how the experiment, is going to be initialized. And then you have also some global options here. For example, how wide should the content be displayed on the screen and what should happen once the study is done. So you always have in every experiment in a jsPsych. And when it's done, you have a function that you can use to have the program do something. In my case, as I'm using Prolific. So Prolific is the platform where subjects find the experiment and click on a link. And after they are done with the experiment, they also need to be led back to Prolific. And this can be done automatically without them having to click a link. You can do this automatically by having this prompt here that gives the return link to the platform from where subjects were accessing the study. All right, so this is also something that is not specific to this cognitive science experiment I want to talk about. This has to be done in every study. All right. Now I'm going to insert some more optional code, which strictly speaking can also be neglected if you don't want that. But I'm putting it here so you can see what I usually have. So first of all, I'm creating a variable that I call condition. Later on in the next video where we talk about hosting the experiment online on cognition.run, I will also say more about this line here because, so I'm not going to talk about this now, but I'm creating a variable that I call condition. And I call this an internal condition variable. Why? This will make sense when we talk about this line here. And then what I also want to do is I want to add the condition variable as a column to the data frame that is going to be generated. So I call the jsPsych data and add some properties, and I add the condition variable that I created here, and the name that it's going to have in the data frame is also condition. Okay, and then also something optional is a subject code that I generate. So I create a new variable that I call subject code, and then I have a little function here that creates a random string in the end, consisting of all the letters, capital and small letters of the alphabet, and all numbers from all digits from 0 to 9. All right, and then, so this is also, you don't have to have this, absolutely optional. I'm just going to say that here. And then here I have I create a variable that I call subject code, and this accesses this thing here, this function make ID, and creates a 12, a string consisting of 12 symbols. And then I have the console log prompt here, so we don't need that anymore actually, but if I run the experiment and open the console, I would see the subject code that was generated here. What is more important is to add the subject code to the data. So again, I'm going to the jsPsych data prompt here, and I add a property. I add a column called subject code, and the entry is the subject code the content of the subject code variable that I have just created. Okay. So far, so good. Now let's proceed to something that is more specific to that experiment here. By the way, what I'm doing right now is, as you might have guessed, I'm copying code from the demo that I already showed in the beginning of this video, but I'm going to say a little bit more about the stuff that I'm copying here. So as you know, jsPsych, a crucial concept in jsPsych is the timeline. So whenever we create an experiment, we have to have the timeline as a variable. And in this case, it's a variable that is going to be a list or an array. And in the beginning, it's empty. There are no elements on the timeline. This is going to get filled as soon as we have elements that subjects should actually see. Now, as I said in the beginning, it is nice, or it's a good advice to preload any images that are going to be shown to subjects. In this case, I had this university logo, and I had an illustration that was this little mouse in the beginning. So I'm going to load this, and then we have the different experimental stimuli, so the different panels of mice that instantiate different sample sizes and different contingencies. So I'm going to load all the images here, preload all the images that are going to be shown in the experiment. And this works as follows. We have a preload variable that is of the type jsPsych preload, and then I'm going to do what is defined here is a list or an array of objects, picture objects or image objects, image files in this case. And I have to say where these files are. So you have to specify the folder. And as I said in the beginning, we call this folder EMG for image. This is where all the files are. So we have to write this here. Okay, and then it's good that we already created the timeline, because the preload variable here is something that needs to be pushed to the timeline, even though it's not something that subjects will ever see, right? They will never see, for example, or they will never see this array of images on the screen, right? But still, for this preloading here to become active when the experiment starts, we need to push it to the timeline. Okay. Now, what I'm also going to do is to set up or create some experiment-specific variables. So here I created a variable I, which has value 0. You could also have left this empty, I guess, which we are going to use later, but it's some sort of a global variable, so I decided to specify it here in the beginning. Then some other things that we will access later is the Likert scale, the rating scale that subjects see. I will say more about this later. So I created a variable called Likert scale, and then another variable called scale orientation. As I said, the orientation of the rating scale, high certainty on the right side, or high certainty that a causal relationship exists on the left side. This is counterbalanced between subjects, and this is some information that I'm going to handle or store in this variable scale orientation. Then there's a variable called scenario. Let me just check if this is maybe not a relic from an earlier experiment, or whether I actually access it in the code later actually accesses it in the experiment. Oop. Okay, as far as I can see, scenario is not something that was actually used in this experiment, so this variable can go away. We don't need that. Okay. Now, as you might also remember, what we saw when I showed you the experiment was that it ran in a demo mode. So it might make sense to have this demo mode option that you can simply not display when you run or when you test real participants. But it might be it's nice to have it in the code. So in case you want to have a demo mode for this study, you should have that. So what we saw in the beginning was a screen that informed the user that this experiment was in a demo mode, and then asked the user to say which condition they wanted to see. So what I do here now is I I have to decide how a user is going to select the condition. And in this case here, this was handled by having the user type in a number of the condition. So I'm going to use the jsPsych survey text plugin here. We create a variable that I just called it select. You can name it whatever you want. So I called it select, and it's of the type jsPsych survey text. And then I'm calling the question attribute and specify the prompt. So as you saw, the text that was displayed was that this study is in demo mode and please select a condition between 1 and 4. Then there was another prompt here. I'm sorry that this is not so well formatted right now. Let's fix this right away. Okay, maybe like this. Yep. All right, so there was the little description of what the user can do here. And then this placeholder attribute of the jsPsych survey text plugin. This is like the placeholder that is written in the text field where you can type like a little piece of information telling subjects what they are supposed to type into the text field. In our case, this is a number between 1 and 4. You can write here whatever you want. Now, if you want subjects or a user viewer of this experiment to give a response here, we can say that a response is required. So this can be true or false. We set it to false, then this screen here could be skipped without a response. But this is something that we don't want most of the time. So we set this to true. And we can also give an internal name to this question here. And in this case, I named it conditional for condition selection. Okay. And then what would also be nice is to store in a data frame which condition was selected. Not necessary if it's in demo mode, I guess, but still we could save the selected condition here. So after having defined the question here, we can specify some more global things here in this select variable. So what I say here is on finish. So once this user input, the screen is done, we proceed to the next screen, something should happen. Well, on finish, a function should be called that does something with the data. And what it does is it specifies the value of the condition variable that we created. Where did we do that? That we created here. In the beginning, it was empty. Now, after having selected condition and pressing continue, this variable gets assigned a value, and it gets assigned the value of the response that was given to this question here that is called conditional. So I'm writing condition, the name of the variable, and the assigned value is data response to this question condition selection here. And then we might also give this back to the console. So what did we do here? What is this part here? How does it look? Well, let's just go to the study. Oops, I'm going to start the experiment that I showed you earlier. So this is the screen we were just implementing using the jsPsych survey text plugin. And I talked about the console. So when I mentioned this code here and said we can also have the condition displayed in the console, what do I mean by this? If you're not already familiar with this, in every browser you can call the console to see what's going on behind the curtain, so to say. And yeah, on Windows or maybe as you can see, I'm using Google Chrome here. And I think yeah, it's true for Google Chrome, I guess. You can call the console by pressing this here. Yeah, I'm using a German keyboard in there. It's called strg. So this means Steuerung, and then Shift, and then I. But you can simply Google how to open the console with the browser or the system that you are using. But yeah, then this window pops up and we can see the stuff that we asked jsPsych to display in the console. So right now we see this code here. This is the subject code that we created and sent to the console. Now I'm going to select a condition and I press continue. And then you can see that this condition that was selected is also displayed in the console. Okay, but now we are already on the next screen that we haven't even programmed yet. So I'm going back to the code. I just wanted to give you an impression or to show you what this thing here actually is. Okay, and what we also want to have is this little feedback screen that tells the user which condition was selected. So let's do this. Let's have a feedback screen. Yeah, in this case, we don't need any response from the user except the button click to proceed. So the way we are going to set this up is create a variable that we may call condition selected, and then use a plugin that doesn't require any more input than a button response. So we can use the jsPsych HTML button response plugin. And then now the next step is important because now we want to display the condition that was just selected on the previous screen by the user. So when we define the stimulus now, the content that is going to be displayed, we have to access a variable whose value was determined by user input on the previous screen. And in order to access this, the value of this variable that got a value assigned in the course of the experiment, we need to call a function. So okay, before we do this, let me say, in general, we could just have, I guess, a string and say, hello, this is some text, or in this case, condition selected is 1, and then this is a fixed string, right? But obviously, this is the wrong prompt if somebody selected a condition that is not condition 1. And in this case, to have as a stimulus the content of a variable that got its value assigned in the course of the experiment, conditional, or as the result of a user input, like in our case now, this cannot be done by writing the variable here, because then it would give the wrong feedback. It would show the value of the variable that it had when it was set up in the beginning. There it was 0. So this is obviously wrong. So whenever a variable gets dynamically updated in the course of the experiment and we want to do something with the current value, we need to wrap this in a function. So we need to write a function here. But this is the whole trick. Well, we also have to tell the function what it is supposed to return. And now we can have the text that we want that stays fixed. And now we can insert a variable. And in this case, by having this wrapped into this function, we are getting the current value of this variable determined here on the previous screen by the user input. So this was crucial here at this point. Okay, now since this is an HTML button response plugin, we know that there's going to be a button displayed on the screen, and we can say what the label of this button should be. So by going to the choice attribute of this plugin, we can say that the button should have the label continue. Okay. Now we have created two elements, two variables that actually represent something that subjects should see on the screen. They should see a select screen where they select the condition, and they should see a feedback screen displaying the condition that was just selected. So now, obviously, we need to push these two elements to the timeline, right? So we could do this later, but we can also do it now to get it out of the way. So we are going to write timeline push, and then we list the elements that should be pushed at this point. And this is the select variable where we select the condition, and it's the condition selected variable we just created. All right. Now, at this point, the time might have come where we want to see if this part of the experiment does already actually work. At this point, we have a timeline with two elements, so this is something that should already work. This code will not work because the script isn't properly closed. So I'm going to insert this part that we need at the end of every experiment now. Like the bottom line, once your code is done here in between these lines, we need to say that a jsPsych experiment should actually run the timeline that we have created. And then we also need to close all the coding. We need to close down the coding area, so to say, by having the closing command for script and for HTML. Okay, now if I save this, we should already have a functional experiment. So let's go to the respective folder. We were working on this demo file here that we created in the beginning. So now if I double click, we see a white screen. And this means that something is not right. And this is also, this is the most important. This is where the console is absolutely important, because now we can see in the console, we can see the error messages that are being produced. And we are getting the line. Okay, and what we see here is that it failed to load some resources, and this might probably mean that I did not yeah, I guess what's wrong here is, okay. Yeah, we downloaded the jsPsych files, but now all the plugins are actually in this distribution folder here. So this is, I guess this is new in this version. So there are two options now. One is to go to the dist folder and take all these files, copy them, and have them directly here in this jsPsych folder. Or alternatively, what we can also do is we extend the path here and say that it should go to the dist folder. So I'm going to do this. Oop. So I guess we got these error messages because the file path here, they were not correctly specified. Okay, now I save again and I'm refreshing the experiment in the browser, and now you can see that this has fixed the problem. And we see the two timeline variables that we created. This is the first one. We select a condition, and then we get the feedback and see which condition we chose. And we can also see that the right stuff is is returned here in the console, which we can close now for the time being. All right, this is already a functional experiment, but obviously not what we want. So we can go on. I'm going to push this part here a bit further down below so that it's a bit out of sight and it's not going to annoy us while we continue making our experiment more complex. So far we have worked on the elements that are only displayed in the demo version, right? So most actual subjects would never see that. The first screen that a real subject would see is this confirmation screen where they say that they are taking part via desktop or laptop and that they are willing to take the study seriously. So this confirmation screen is the next element we should program. And as you remember, or might remember, or I'm going to show it again. Going a bit back and forth here. What I'm talking about now is this screen here. We need to set this up now. Okay. Let's go. I'm going to insert a little comment here. And now I'm creating a new variable. I call it conf for confirmation. Now, what type is it? Well, it's a multiple choice. I went for a multiple choice screen here. So type is jsPsych survey multiple choice plugin. And then we have to define the questions. And we can actually have multiple questions. And this was the case on this screen. So I'm creating the first question here, which has a prompt. I'm just going to copy the text here. The video is already going to be long enough. Okay, this is the prompt for the first confirmation question. Then give it a name. This can be whatever you want. This is the attention confirmation. And then we have to define the options. The first option is I will take it seriously. Oh no, this is the, oops, sorry. This is not the attention confirmation. This is the desktop confirmation. So the first option is I confirm. And the second option is I do not confirm. Okay, then we can also say that a response to this question is required. Okay, now we are done with the first question. We can do the second question. It has obviously the same structure. So I'm just going to copy this from the code that I already programmed. Again, a response is required. Okay, now we have set up the questions, specified the options, and said that answers or responses are required. And we are actually mostly done. But this is a screen, this confirmation screen here. This screen here is something where I do some stuff with the data. It's the first screen, and I can use it to specify some variables that are going to be used later on when subjects press continue. So what am I going to do here in addition to stuff that is going to be displayed on the screen with this jsPsych multiple choice screen? Once the subject is done on this side and presses continue, I want some stuff to happen. And this is a routine that I developed. This doesn't have to be done here. But I've come to like it that way. So I'm going to do some stuff with the data. And I'm also going to give a comment that tells you what I'm going to do here. Well, I'm reassigning the values of some conditional of some variables. First of all, we have all these different between subject conditions, right? 4 between subject conditions, large sample size and small sample size, and then counterbalancing of the rating scale that subjects are subjects see in the course of the experiment. So I can specify some variables for the different conditions on this screen. So for example, if condition is 1, I can say that my scale orientation should be, or I can tell the variable of my scale, I can tell the scale orientation variable that in this condition, the option that it's not a cause, right? The chemical does not cause the expression of the gene is, this is the label, this label is displayed on the left side of the rating scale. And by writing this into a variable, I can later have a column in my data set that has the name scale orientation and specifies that it's not a cause option was on the left side of the rating scale in this condition. Now, I also should actually define the rating scale. So I'm going to call the Likert scale variable and then define the variable here. So, and since my scale orientation variable here takes on the value not cause left, I should better write down or specify a scale here that has this specific prompt on the left side, so certain that it does not cause the expression of the gene. Okay, and this is how we set up a rating scale. You can count you can make this list longer here to have more options on the rating scale. In this case, we have 2 labels, one at each endpoint, or 2 endpoint labels, and then we have fully uncertain in the middle, and then in between we have radio buttons or response options that are not labeled at all. But in total, we have an 11-point rating scale here. And this could be different, right? I could delete options here, or I could make this go away, and then we have no labels at all. So this can be tailored to your needs. In my case, I wanted an 11-point rating scale. Okay, another variable I'm going to assign a value here is sample size. In this case, I'm specifying that in condition 1 is a small sample size condition. Okay. Now we have more than one condition, right? So we also have to say what should happen if it's not condition 1. So if the selected condition is 2, what should happen then? Well, you can decide what should happen then, and I'm going to copy the code. But the structure is just the same as before. So in this case, sorry, I just copied condition 3. I wanted what I had in condition 2. So what I do here is just is to establish that in condition 2, the scale has the opposite orientation, but sample size doesn't change. But this changes if we go to condition 3. So now I'm also already going to copy condition 4. Yep. Okay. In condition 3, we have again the same orientation as in condition 1, but the sample size is going to be the large sample size. So the many mice. The same for condition 4, but again here we have the scale orientation that we already implemented in condition 2. All right, now it would be nice to have this information as columns, to have the values of these variables as columns in the data frame. So now again, when as I said before, we are here in this unfinished part. So as soon as subjects click the next button, this screen is finished, and then we have these variables declared and we add them to the data frame. So I'm going to write jsPsych .data to access the data object. Then I want to add some properties, and these properties are going to be all the stuff that we need from this screen here. And remember that in the beginning, what we built here was a screen that asks subjects for confirmation, which is obviously something that we also want to store in our data frame. So I'm creating a column in the data frame, desktop confirmation. And the content should be the desktop confirmation response here. And this name of this question was desktop conf. So I'm going to the data object where this has temporarily been stored. Go in the data object, go to the response object, and there access the value of the question called desktop conf. Now I have to write it in exactly the same way as it was specified here above, desktop conf. Now I can simply write comma and create the next variable, which I call attention conf. Then the same game as before, response, data response, and then it's the attention confirmation question. Okay, now I stored the values of these variables from these questions here, but I also want to store these additional variables that we recoded here. Now or not recoded, that we gave some specific values here in this unfinished part of the function of this variable. So I'm just going to copy code from the already existing code. What we really want to know here is what was the scale orientation in this condition and what was the sample size. So I'm also going to add this to the data. Okay, now we are done with this unfinished part here. So I'm going to close this, and then the survey multiple choice plugin also has another attribute called the preamble. So the preamble is all the text on the screen that is not a question, but should be displayed. What is it? It's this part here. This part here. This is already part of the question, right? And this is part of the preamble. So I'm going to specify this here at the end. And again, I'm just going to copy this text from the already existing code, because there's just no point in having you watch me type all this stuff. Oop. So as you see here, we have the logo of the university first. So I'm going to insert this image here, and this is HTML code that I'm not going to talk about in this tutorial. Okay, so we have this preamble set up, and now we are actually done. This should be a semicolon. Close this part. Now we should push this to the timeline because it's ready. So we push the confirmation variable to the timeline. We save, and we should refresh our demo to see if it's working so far. As you can see, it's not working. We have an unexpected identifier options. Let's see what the problem is. Okay, I had to look what was going wrong here, and now I found it. So the console told me that there's a problem with this option identifier in line 144. So then I thought, okay, maybe I misspelled options, but this is not the case. And then I realized that something was missing up here in the line before, which was a comma to say that the next attribute is going to be specified. So now I'm saving it again, and we refresh the browser, and now it seems to be working. So let's see if we get to the screen that we just set up. It should be this timeline variable. Yes, and there it is. We can operate the screen. And now if we continue, the experiment is done, because that was all we had so far. And now we already led back to prolific, which was what we specified in the very beginning here with the onFinish function. Okay. All right, so I just refreshed the screen here. Okay, we can go on. We have the confirmation screen. We also assign values to some important variables that we want to store in the data frame for each condition. Now we can move on to the first real screen of this experiment, which is the instructions. This is very straightforward, so I'm just going to copy the code, but I'm going to say something. So we create a variable that we call instruction, and in this case, subjects are just supposed to read some text look at an image, maybe this little mouse and the pipette with the chemical substance inside. But again, apart from clicking on a button to proceed, there's nothing that we ask them to do. So again, this is the good plugin for an instruction is usually the jsPsych HTML button response plugin, which again has the stimulus attribute where we can write down all the text that we want to be displayed on the screen. And then we have to say again what the label of the button should be. And in this case, it's again continue. And then we push it to the timeline. Now I'm going to save again, and I'm going to work myself through all the stuff we have so far. So instead of going back to prolific, we should actually see a new screen, which we don't. Wait a second, did I save? I think I forgot to refresh. Yeah. So what I did is I saved the current version of the script, but then I went ahead and didn't refresh the window in the browsers, and therefore we didn't see the new timeline variable we just created. Yeah, and there it is. And now we can go on. Everything seems to be working so far. The next thing that we want to have is the comprehension test or the instruction test. Subjects learn the most important part of the relevant information on this screen, on our instruction screen, and now we want to probe their knowledge, and we want to make sure that they can proceed to the main part of the experiment only if they have understood the relevant information. So now we are going to implement a comprehension test. Let's first go back to the experiment. So after the instruction, the comprehension check looks as follows. We have two questions. The first one was, what do the biologists want to find out? And the correct option was whether certain chemical substances cause certain genes to be expressed in mice. And then the comprehension check question had actually a second screen, which was, how did the biologists test their question? Well, the answer is they conducted experiments with random samples of mice assigned to control and treatment groups. And then again, if we give the wrong answer here or on the previous screen, we should see a conditional screen popping up once we made a mistake and telling us that we did not answer all these check questions correctly. We go back to the instructions, then have the chance to take the test again. And if we answer all questions correctly, we should see a different screen that tells us that everything was right that we said, and that we can now proceed to the main phase or main part or the next part of the experiment. Okay, this is something we need to implement now. So, and this is something I'm going to code and not just copy paste, so that you can see what I'm doing. I'm calling this instruction check 1, because we have actually two screens that are part of the comprehension test, the first and the second. So the first one now we want a response from subjects in some sort, right? And this, as you could see, was realized by having them respond to multiple choice questions. So we are going to use once more the jsPsych survey multiple choice plugin. The name is instruction check. And now we have to specify questions. So as you can see, we are using a plugin. There's not a comprehension test plugin, for example. So we use the survey multiple choice plugin that we used here in the beginning, where we asked for subjects confirmations. So this part here, after having specified what plugin we want to use, I can simply copy paste content of the first question, because it's something that you have seen already. There we go. So there's going to be a prompt, which is the question, what do the biologists want to find out? And then there are options, which you have also seen before. All right. Yeah, this looks a bit ugly. Sorry. Okay, let's leave it like this. There are the 4 options. Okay. Then again, it is very important to specify that a response is required here. And then we give a name to that question. This up here was the name of the variable. Actually not so important in this case here. What is more important is a name of this question on that screen. Okay, we could now have a second comprehension test question, right, on the same screen, but instead I went for the option to have 2 separate screens. Again, we probably want to have, since this is the first screen of the instruction test, we should probably tell participants that this is an instruction test that they need to pass. So I'm going to insert again a preamble. That is going to inform subjects what this is. All right. Now, once subject press continue, we probably want to store some information. So again, I'm going to insert the onFinish, this onFinish part, and I'm again going to call a function which does something with the data object. First of all, I'm going to handle this I variable that we had set up in the beginning, and it had a value 0. Now this gets updated. So on finish, as soon as subjects press the continue button, so let me go to the screen on which we are currently working. This question here, as soon as they click continue, this I variable will get updated. So it will take, after the first click on this button, it will get the value 0 plus 1. So it will take on the value 1. And now you can maybe already guess what I'm using that variable for. I'm using it to store the number of times subjects looked at these comprehension test screens, because this is going to tell me how many attempts it took them to pass the comprehension test, which might be relevant to decide if you want to use their data or not. We can also write this to the console when we are trying out the experiment to see if everything is working correctly. So let me also insert a little prompt here. This is optional, right? You can leave it out. You don't have to trace anything to the console. But now the console gives me the current value of this variable I and says how many instruction rounds have been done. All right. Now, I can also, on this screen, determine whether the questions here were answered correctly or not, which we later have to use or need to use again to decide which feedback screen we want to display. So first of all, I'm going to add subject's response here to the data. And the name of the question on the screen was goal check. So if in the data object, the response to the question goal check was this, then, well, then what? Then somebody obviously gave the correct answer. So the instruction check, a variable called instruction check 1 is going to take on the value correct. Obviously, since only one option is correct, if something other than one was selected, then instruction check 1 should obviously specify that what subjects did here was not correct. All right. Let's also trace to the console what the variable value of instruction check 1 is, what the value of this variable here is. Result instruction check, and then the value of this variable. Okay. Now we should add to the data frame the content of variable y, so that once we have collected all the data, we will have a column that tells us for each subject how many rounds of the comprehension test they did. So we add properties to the data. In this case, we create a column in the data frame that we call instruction tests, and the values written in this column should be the value of I for each participant. All right. Now this should be the first question of the comprehension test. So we push this part. So now I realize that something that was not actually optimal. So I created a variable called instruction check here that handles whether something is correct or not, but the timeline variable here also has the name instruction check 1. This is maybe not optimal. I should have named it differently, but it's also in this case not going to be a problem. Well, let's maybe rename it. First part. Okay, now I'm going to save and I'm going to check if that actually works. So this is the current version of the experiment. Let's go to this part. There's our question. It's being displayed. This is nice. And now if I press something, the study should end, right? Because we haven't done anything more so far. Yes, and it does. Okay, this seems to be working. We should also, let me go to the screen one more time, because we should also check if the right stuff is presented in the console. Whoop. Let me do it again. Okay, we can now, since this is jumping to prolific to the end screen, we have almost no chance to check the console. Let's go back. Let's return later on. So far, there were no errors. Everything seems to be fine. So let's continue, because we have a second part of the instruction check, right? I'm just going to copy and paste it. because it's exactly the same thing, just a different question. So we call it instruction check part 2. No, second part. Again, it's a multiple choice question. We specify the question. We have to keep in mind what the correct answer is. This time we call it method check, because the question is, how did the biologist test their question? So what was their method? We have a preamble. This time it's much shorter because subjects know already that they are in the comprehension check phase of the study. But then we finish the data, and then we have now to say that if the response to the method check question was first option here, this was their response, they selected this option here, then instruction check 2 should be correct, and else it should be incorrect. Again, we can trace it to the console. So far so good. Now we also have to push this object to the timeline and save. And now let's see what we get. We get an error. I already know what it is. I was too fast. Our timeline variable is called instruction check second part. So what we should write to the timeline is instruction check second part. I'm saving again. Now let's start again. It seems to be working. Let's go to this part. First part of the instruction screen, I select something. So in this case, we see in the console that we have one round of instruction tests, that we selected the correct answer. This seems to be handled correctly. Now we take number 3, and okay, now I stop here because this will, after pressing continue, will go back to this prolific screen again, which we don't need now. Now we have 2 comprehension check questions. We also have conditional statements here that code if somebody gave the correct response on each screen or not. Now we have to do something with that, right? Because we only want to let subjects proceed to the main part of the experiments if they did everything right, and if not, they should go back to the instructions. So these conditional screens that should come next have to be set up. The first part of this conditional feedback part of the comprehension test is straightforward. I just copied one of the relevant elements from the existing code. First, we set up a variable that we call instruction check failed, which obviously, as you can tell from the name I gave to that variable, is going to be the screen that gives the feedback that not all questions have been answered correctly. And this is just a simple HTML button response plugin question, because subjects just have to take note of the fact that they didn't answer all questions correctly, and that they will go back to the instructions screen. And so I relabeled the button, and instead of continue, I labeled it back to the instructions. So far so good. We are not going to push this element here to the timeline because we don't want it to be always shown, right? We only want it to be shown if subjects make mistakes in the comprehension test. So no pushing to the timeline right now. Another thing that we have to keep in mind is that what happens if subjects make it wrong? Well, they go back to the instructions. They read the instructions again, then they come back or return to the comprehension test and get another chance to pass it. If they mess it up again, they should see the very same screen and again return to the instructions, take the test again, and so on and so forth. And this goes on until they make everything right, or we have specified a certain number of rounds they are allowed to take, and then are led back to a different screen telling them that you made too many mistakes. The study ends here for you. But this is not what we are going to do now. Now we create what could be called an endless loop that keeps leading them back to the instructions and doing the instruction test until they finally pass it. I guess this is feasible here because we only ask 2 questions. So at some point, subjects should be able to do it. All right. So now this process that I just described is a loop, right? We want to send subjects to a loop here that has a certain that goes on, it keeps looping until a certain criterion is fulfilled, namely correct answers to both questions, and then stops the loop and subjects proceed to the next part of the experiment. So now we need to set up a looping function. And this is going to be just another variable that I will give it the name loop node. Or yeah, I don't know why I once started with the idea to call it a node. Let's just call it loop maybe. And then what this variable, so now we have to specify what, obviously the loop variable in it by itself is nothing that subjects see, right? It's a variable that handles what it's going to see. So we have to say which timeline elements, so which stuff that subjects will actually see on the screen should be part of that loop. So we can tell what should be part of the timeline while a subject is in that loop. Well, one part obviously should be the screen, and this should be the first part of this loop, right? The screen that the instruction check has not been passed, that a participant failed. And then we want to have the instruction again. And then what's supposed to happen next? Well, subjects should have the chance to pass the instruction check again. So we should have the 2 comprehension check questions. So do we need anything more? No, because once we reach instruction check 2, well, we have to decide again if it was passed or failed. If it was failed, this screen should come next. And this is already part of this timeline array here. So I guess we have all the elements. And obviously, another screen that informs subjects that they passed the instruction test, this should not be part of the loop. Instead, this should be the first screen variable or the first screen after the loop, right? Okay. So now, when should this loop, what should this loop do? So first of all, or we also have to keep in mind that at some point this loop should be triggered. Okay, I'm going to leave this here. This is not done yet, but keep in mind that there must also be a decision criterion that establishes or that specifies whether this loop should loop through this timeline array here or not. And this decision needs to be made outside of this loop. So we know that we are going to need this loop thing here, and there must also be a decision whether or not it should get triggered or not. And this needs to be outside the loop variable. So I leave this part of the code here. It's not done yet. We will return to it momentarily. But let's first work on this decision, if this should be triggered at all. This is a bit counterintuitive because it actually needs to be specified after the loop, because inside of this decision rule, we need to refer to this variable. So it should be there before, I guess. So now I'm just calling it an if. Well, in the past I called it if node. Maybe that's not the best description, but let's go with that. This is going to decide, this variable is going to decide if this loop is going to be triggered or not. Okay, so again, we need to say what's going to be pushed to the timeline. Well, if it gets triggered, what should get pushed to the timeline is the loop. even though the loop in it by itself is no content, right? But inside the loop, there are all these timeline variables that actually display some content on the screen. Okay, but this is what should get triggered if the criterion is fulfilled, and the criterion is that the instruction check was failed. Good. So now we need to handle this. We need a conditional function. Or at least this is one way to do that. We need a conditional function, and this conditional function should check if instruction check 1 is incorrect, or, this is also important, we need to have the logic or here. We cannot write n, right? Because then subjects will still proceed if they answer only one question incorrectly. If they fail both. But we want to trigger it as soon as they get one question wrong. So the if node should become active and activate the loop if either the first or the second instruction check question has been answered incorrectly. Now we just say return true if this criterion is fulfilled, and else if it's not fulfilled, what we're going to do is not return it. Okay, this is all done. Now, this is something that definitely should be pushed to the timeline, right? Because after the instruction screens here, we definitely should activate this evaluating component that tells us, or that checks if the instruction check was passed or not. So we push the if node through the timeline. So I'm going to insert a little comment here so that you know or remember once you work with that code what's happening here. Now we can return to the loop. So let's say one or the other or both questions were answered incorrectly. Then we know that this if node that is on the timeline now is going to trigger return true, and upon returning true, the next variable that becomes active is this loop variable here. And we don't have to push it. We don't have to push the loop node to the timeline outside of the variable, because this is already specified here in the timeline prompt of the if node. But now we are not done. We are not done with the loop, because if we left it like that, what would happen is that the instruction check is not answered, is not passed. This if node returns true and triggers the loop node, and then we would keep looping, right? So we need a stopping criterion for this loop to stop, and this is what we are going to specify within the loop variable here. We don't want to have an endless loop. So now we use the loop function, and again, well, not again. Now in this loop function, we are actually calling the function that checks something that is going on with the data object. In the data, well, I guess this is not, we don't need that here. Okay, because we didn't use it here. Let me take this out and see, and we will see if it works. So let's just call a function. And let's let's define the criterions. So this is basically the same as below. We check instruct, but now we are checking the status of these variables within the loop. Therefore, we have to call them here again. But I'm actually going to write exactly the same stuff that we wrote below in the if node. So as long as questions are answered incorrectly, we want to keep the loop going. So we say return true. Now what the loop function does is it keeps looping through the timeline variables defined up here. And obviously, if both questions are answered correctly, we say return false, and this is the stopping. This is the point where this loop would stop. Okay. So far, so good. This is the structure here that basically handles the looping through the comprehension test. Now, we also want to have a screen that pops up or is presented when subjects have passed the test. And this is very easy again. We can just define such a screen variable here after this whole comprehension test loop stuff. So we again create a jsPsych HTML button response screen, and we write the message that is going to be presented when somebody has passed the test, and we push it to the timeline. It's no problem to have this to push it to the timeline here, right? Because unless the instruction checks have been answered correctly, we are in that loop, and this screen here never happens to be seen. Okay, I'm saving here, and we can go to the experiment and see what happens. Okay, as so often, I'm getting an error message here. Instruction check 1 is not defined in line 309. So it's always good to have the console open, as you can see. 309. Instruction thing. It's check 1. It's check 2. Yeah, remember that we relabeled the instruction check variables. So what we should write instead is instruction check first part and instruction check second part. All right, I save again and restart, and now it seems to be working. So let's see. Instruction, first screen of the instruction test. I'm selecting a wrong option, continue. I'm selecting a wrong option again. Okay, and now something happens that was supposed to happen. We get the feedback that we made a mistake, and now we should go back to the instructions, which is exactly what happens. Now we get a second chance to pass the test. So let's do it right this time. And now we get the other screen, right? You answered all comprehension check questions correctly. And now we can continue as the main part of the study. And this is what we are going to set up next. Oops, some comment. Test phase of the study. Now we need all the different test screen, right? We just to remind ourselves, we have a between subject. What we want to do, what we want to have in the end is a between subject design. There's one between subject, theoretically relevant between subject factor, which is sample size. So whether or not subjects see a contingency table with a lot of observations or with relatively few observations. And then there's another between subject factor, but this is not theoretically irrelevant. That's just the orientation of the rating scale, right? But yeah, so now we need to do this, all this stuff. Okay, now I'm not going to copy and paste. I'm going to program. I'm going to write the code here because we are going to use a new plugin that we haven't used so far. We had the multiple choice plugin, but now we are going to use the jsPsych survey Likert plugin, where we will have a screen that will display a rating scale. So let's start with one of the test cases, and I'm going to name this, or yeah, I'm going to declare a variable with a name that shows me what it's going to display, which condition it is. So this is the small sample size condition, 32 observations, and the contingency, the correlation that subject C is 0.25. Maybe that could have been a better name. I don't know. I'm going to leave it at that. Now we want to use the jsPsych. So now we use the jsPsych survey Likert plugin. That's what it's called. I hope I didn't make a typo here. We can also, like, okay, maybe that's a good moment to check out the website again. So as you might know, if you don't know what plugin to use or how you have to write the code, what the exact name is, then you can go to the website and go to the list of plugins. And then you get a list of all the things, all the plugins that are available together with a description, right? And then, so now we want to use the survey Likert plugin, survey Likert. You can also click here and then we get, even more information, for example, about the parameters available in all plugins, but then also the specific parameters of that plugin, like randomized question order, and then you can also learn how you have to declare it in your code. So for example, this is a Boolean variable, it can be true or false. And then you can see that this type of plugin also has a preamble, and then you can also learn what data it generates, how you can get it. So here, right, this is, if we have downloaded all the jsPsych plugin files, then this is what we have to declare in the header here that we looked at in the beginning, right? Except that we had a little bit little different folder structure. We had the subfolder dist, which is not yet part here in the documentation on the site, right? Okay, but yeah, this is where you can learn. And then there are also always demos. So you get a code and then a demo, and then you can try it out. Okay. All right. Yep, let's continue here. We declared a variable and called the jsPsych survey Likert plugin. Now it's time to define our questions. There's going to be a prompt. This is what I'm going to copy. No need to wait until I have typed all that. This is going to be the prompt. And then whether or not this will be used later, we will give a name to that question, which we call rating n 32 0.25. So it tells us again in which condition this variable was shown or was used, or pushed to the timeline. Then we can this is now the label the label option here, this is something that is specific to the survey Likert plugin. We have to say what the labels of our Likert scale are. And as you know, this is dynamic because we have a between subject factor that where the Likert scale has either that or the other orientation. So now, if you remember, we have declared the orientation in the beginning, so we don't have to deal with that anymore down there. And we have created the labels and have written them to the Likert scale variable up here. So now you know that when we want to call a variable whose value got reassigned in the process or during the experiment, we need to, and we want to access the content of that variable, we need to call a function. And in this case, the labels are already declared further up. So what we want to do is we want to return the Likert scale variable, because depending on condition, this has a certain orientation. All right, so far so good. Now we are done with that question here, and then we jump behind this curly bracket here because now we want to declare a more global option in that variable. We want to, well, now we have only one question on that slide or on that screen. But in theory, what you could do here as well is define or declare whether the questions on that screen, if you have more than one, should be in random order or not. In our case, it doesn't matter. We actually don't have to specify that, but I just wanted to mention that here. We set it to false. We have only one question anyway. Now we can declare or define a preamble. This is where we give subjects all the information or all the text. And this is something that I'm going to copy again. Oop. This is the text and picture. So remember that the contingency and the sample size are conveyed by a particular test stimulus, the picture that shows the mice, right? The experimental and control group. So we have to insert a picture here. And in this case, it's the image that has the name n32.25.png. It's a PNG file, and we also set the width to 50% because it doesn't need to be so big that it covers the whole screen, width of the screen. Now, okay, this is all done. Okay, I'm going to say a bit more about these test cases in a second, and we'll address the question whether this could also be done with less code, but I leave it at that at the moment. I will say something about that later. Now we must not forget that we probably want to save something here to the data, because this is a screen where subjects give the most important response of the experiment, right? This is the screen where we assess the main, where we do the main dependent measure, right? The main dependent variable is on that screen. So on finish, once subjects have given a rating and press continue and leave this timeline variable, we should save something. So we call the function and the data object inside the function. And as so often before, we add a property to the data object. And in this case, what we declare a new variable in the data frame. I call it rating 0.25. And then we access the data object, we access the last response, and then have to type in the name of that question. And in this case, this was rating in 32,025. Okay. So far, so good. This is done. And of course, this is not something that every subject will see. This depends on the condition, on the between subject condition one a subject is in. But just to see if it works, let's push it to the timeline anyway. This is going to go away later. I just want to check if this is working. So I push it to the timeline, I save, and then all right, there's already an error, so probably good that we tried it. What is the problem here? Check the console again. Unexpected identifier labels. Yeah, and as before, I forgot to put a comma here. So this could not be interpreted. Okay, save again. Okay, there's actually a new error. 360. Yeah, here I put a semicolon. This was wrong. It needs to be a comma. Save. Okay, and now the survey Likert is not defined. So we have again an error. Yeah, and you can already see there's a typo here. I wrote survey. So I didn't write it correct. And now it's working. Okay, so you see how important it is to work with this console. Yeah. Now let's see what we have so far. Okay, now we ended up on the feedback screen that tells us that we did not answer all questions correctly, even though I'm pretty sure that I did. And in the console, it's also telling me that I actually did. So there's something going wrong in the code. So let's check this out. And so there's a problem with the if node, and I already spotted. The problem here is that I just wrote false and forgot to type return. All right, so now let's check again. Confirm, I read the instructions, I take the test. Okay, and now we answered all questions correctly. Well, we did that before, but now the program is also telling us that we did so. This seems to be fine. And now let's continue. Okay, this should be the first test screen, but that's not happening. There's a problem now with the first test screen that we wanted to see here to see if everything is displayed correctly. So let's go back to this part, and then let's try to find out what the problem was. So here, this is a bit of a cryptic error message that we get here. what we learn is that some property cannot be read. So let's check. Okay, so the problem is that I wrote question, but I guess it needs to be questions. Okay, save, and let's try again. Really quick. Okay, this might be a bit boring now. All right. Now we see the question, but we don't see the picture. So what is wrong there? The problem is that I wrote preamble instead of preamble. Sorry. Okay, now it should work. Just one quick run back to that screen. All right, and now we get the preamble, we see the picture, and we see the rating scale. Okay, now that looks fine. Okay, then we can delete this timeline push command here, because whether or not this is shown should actually depend on the condition, so there should be some conditionals later. Now we can set up the other test screens. There are 4 in total, right? So now I just copied this part from the existing code that I already did. This is a new variable. It's just the same as before. It's basically the same code, but I give the variable a different name. This is now the variable or the screen that shows the higher correlation in the same sample size condition. So I adjusted the names, and of course there should be a different picture. And of course also a different entry to the data frame. Okay, now we could check this again, but I'm pretty sure it's working. Now, let me just quickly copy the code for the other test screens. No need to program this here or to write this all down. This is the first screen, so the weak correlation in the high sample size condition, everything the same as before, but the necessary adjustments, right? Different picture, different entry to the data frame. And now, of course, in the high sample size condition, there's also a second screen that shows the higher correlation or higher contingency. Again, necessary adjustments, but other than that, it's exactly the same as before. So now we have our 4 potential test screen, 2 for the small sample size condition, 2 for the large sample size condition. So now this is just 2 screens between subject condition, 4 elements here in total. So in this case, it was not so bad to have like 4 different timeline variables here. This could have been programmed more economically, like more, there's no need to have this 4 times. We could actually have programmed only 1 test screen and then dynamically load the right picture. But this is not something that I want to demonstrate in this tutorial here. With only 4 test screens, it's not too bad to have some more lines of code. But there are ways to do this more code efficiently, so to say. What is more relevant now is that we need to decide, depending on condition, which 2 screens are shown to participants. And we also have to specify that within a sample size condition, what is the order in which the 2 screens in a condition are going to be displayed. Okay, so let's do this now. what I'm going to do now is I am going to create two new variables here that I call test cases N32 for the small sample size condition. And then another one, test cases N128 for the large sample size condition. And these variables are actually going to be vectors. And I put the relevant test screens in that condition, in that vector. So we have test case N32 0.25 and test N32 0.75. And in the large sample size condition, we had test number 28. No, this is not it. Test and merging 28 and 0.25 test in 1.28 and 0.75. So now we have two new variables, the test cases for the small and large sample size condition respectively, and we have the different variables that we created here in this array. And now, because we want a random order, we create two new vectors, vector variables, that I call shuffled. So this is a variable that will shuffle the variables in this array here. And for this, we use the jsPsych randomization command. And we say, go do a randomization. And with what do we want to do that? Well, with now first with the test cases of the small sample size condition. And we want to repeat this only once. We want to shuffle it once. Okay. Before I go on, I will add some comments here that tell you what is happening here. Good. And now, of course, we do the same for the large sample size condition. All right. So far, so good. Since we have two screens in the test phase, we probably want to have an intermediate screen that tells subjects that, okay, you've seen the first one, you have given your response, now you're going to see the second one. I'm just going to copy the code here that we need for this intermediate screen because it's nothing new. It's just an HTML button response plugin that we use. So straightforward. The stimulus here in this code here, it's wrapped inside a function. This is actually not necessary because, as you can see, we are not trying to access any of the variables here. So this could actually go away. Maybe I take it out. It doesn't hurt if it's there, but we don't need that. Okay. I guess it's fine like this. Okay. Of course, this must not go to the timeline now because we're not done yet. We have shuffled our test cases. We have our shuffled arrays. But now we still need to decide whether these cases are going to be displayed or these. This is the between subject condition. Okay. For this, we will now set up conditional timeline variables. So I will add some comments. before I do that. Oop. And now let's say we want to start with a small sample size condition. So I create a new variable. I labeled it N32, goes belonging to the small sample size condition. Then I create a timeline here. No, I don't create a timeline. I call the timeline function or prompt. And then I'm going to say what is going to be shown or pushed to the timeline if this variable N32 is pushed to the timeline later on, depending on condition. So if variable N32 is pushed to the timeline, what should actually be shown on the timeline is what we have in our shuffled arrays here. So I can actually just copy the variable from above. And then I want to show the first entry of that vector. So I open brackets and then I say, show the first entry, and in the vector, the first entry has position 0, right? So I'm typing 0, and then it should show the second test object, right? So I copy that again and say, then show the first element, which is on the position 1, which is the second element. But now we forgot the intermediate screen, right? This should also be there. So we also should then have the intermediate screen. All right. Now, of course, we still need to decide whether this N32 variable should be pushed to the timeline or not. And as you might have guessed, this is again a conditional function that we need here. And then we call a function. And we have to define the conditionals. So if our, and this is what we have set up in the beginning, if our sample size variable is N32, remember that this is something that we set up in the very beginning, right? After the confirmations here. We had sample size equals the string N32 if condition is 1 or if condition is 2. And this is what we use down here now. So if it's that, then what is going to happen? Well, then return true. Else return false. Okay. So what it's doing, here's some comment. And then we do the same for the large sample size condition. Okay, I just copied and pasted it here. But it's the same logic as before. And it gets active if sample size is 128. So here we are referring back to our variables that code the between subject conditions. Now we can just push these two variables to the timeline. Okay. And now let's see what we have. I save, I go to my browser and I refresh. Oh, there seems to be no error so far this time. So let's go to condition 1, which should be a small sample size condition. We go through the instruction, test. Yeah, I did everything right. I continue. Okay, this looks like I'm seeing 32 mice here. This looks good. I provide my rating. I continue. Then there's the intermediate screen. And yes, I see again 32 mice, but I see a different correlation here, a different contingency table. This looks fine. Okay, this is the main part of the study. We have realized the between subject conditions and the within subject conditions. And now we should actually also see those in random order. Let's just check. Let's just do it again. Maybe we get lucky. Oh no, let's not do that. I mean, I don't wanna make this longer than necessary. It's already quite long. But there was no error, so I guess the shuffling works. So now, since you're watching that online, you can be sure that it works, because I will make sure that I don't upload something that won't work as intended. Okay, now what's left to do is something that might not be so interesting anymore, but a real experiment has some like additional part where we ask demographic questions and give subjects the chance to report errors and whatnot. So I'm just going to copy and paste this code here. So we are at the end of the main part of the study. So we assess some demographics. I create a demographic variable. This is a survey text plugin that I call age query. And then I have a question where subjects are asked to indicate their age and type it in as a number. You already know this plugin. We used it in the very beginning for the demo version of the experiment where we select a condition. Okay, and don't forget, or I mean, at least it's nice, I think, to write the values of the response, or to add the responses to the data frame here at the end. Now we might also ask subjects with which gender they identify themselves. So this is a multiple choice plugin, same as before, and I write the response to the data frame. And now I push these two variables to the timeline here. I mean, the demographic, the age question could have been pushed to the timeline here already, but you can also do this later, as you can see here. Okay, now quickly, let's do the screen where subjects can report technical issues. I just copy, because it's again a survey text plugin. But there are some additional specifications I haven't shown you before. You can also say you can also specify the rows and columns of the text field that subjects see. All right, and then I'm adding their response to the data upon finishing that screen. Okay, I pushed it to the timeline, and now the last part of an experiment is a debriefing screen where we tell subjects what all this was about and who they can ask if they have further questions. All right. So a debriefing screen, this is just an HTML button response screen, because subjects just have to read some information and then click on a button, which in this case is called Finish Study. And we push this to the timeline. And then we reach the end of our code. And the next thing that comes here is a command telling jsPsych that the whole timeline should be run, please. And what happens if subjects click finish? This is something that we defined or specified in the beginning on finish. So the last action, this doesn't have to be the finish button. It's the last actions before the timeline runs out. What should happen then? And in this case, we change the window location and we go to a link, which leads subjects back to the page from which they came to the experiment. And this might vary, and it might be different in your personal case. All right. Yeah, this is it. So I save. Let's run the whole thing one more time from start to finish. And comprehension test. Everything right. And now I see the first data set. Intermediate screen, second data set. And now demographic screen. How old are you? 99. With which gender do you identify? yourself. Prefer not to say, I don't know, whatever you want. There were no issues. And then the study is done. I can finish, and it leads me back to prolific. Okay. All right, now we have set up what I in the beginning called a typical cognitive science experiment. And what I meant was an experiment whose design is a mixed design where we have between and within subject factors and a random order of presentation of repeated measures. And what was also quite important in my view was this comprehension test that tests subjects' knowledge about the instructions. And yeah, we usually want to have a comprehension test that brings subjects back to the instructions if they fail to answer all questions correctly. Okay, yeah, I hope this was helpful. This video was a bit long, I have to admit, but I hope it was of help. In the next video, I'm going to talk about how we can make this an actual online experiment, because now what we have is we have an HTML file and we have something that runs in the browser, but it's not really an online experiment, right? It's not really online. I'm running this from the folder here. So in the next video, I'm going to talk about one way to make this a real online experiment with cognition.run. Thanks and goodbye.